Honors Chemistry, and welcome to the back half of Chapter 4. So first we open up with the concept of ions, right? Where ions are, right, something that has either gained or lost electrons, right? And note that it will always be gains or loses electrons rather than protons because, right, every element is defined by its characteristic number of protons. That never, ever, ever changes. So the only thing that can change, and if we think about where things are, protons live in the central nucleus, electrons live in those outer shells, right? Those are the only things that have access to other things, right? Such that they could be gained or lost, right? So to be very specific, right, something that is a cation has a positive charge, right? And that is because it has lost electrons, right? That's how you get a positive charge. Anions are things that have a negative charge because they have gained electrons. Okay, so then when we think about that, right, let's go ahead and do some practice. So determining ion charges. So it says determine the charge of each ion. So if we have a nickel ion with 26 electrons, right, and we would like to know its charge. First of all, what do we need to know? Right, nickel, right? Nickel comes with 28 protons, right? So we have 28 protons, right? And we know that we have 26 electrons. Protons have a charge of +1. Electrons have a charge of -1, which means that equals +2. Yes? Does that make sense? Right? Your book gives you an equation, which is all fine and good. You can go ahead and memorize that. That's fine. But sometimes what happens when we try to memorize an equation, right? What happens if you flip it, right? What happens if you memorize it and you don't memorize it quite right, or in a moment of stress, you get it backwards, right? And then you get the whole problem wrong, even though hypothetically you understand what to do, right? I feel like these are ingrained. You understand that protons are positive, electrons are negative. So if you just sit and put those numbers together, I feel like in a minute you can figure it out. All right, so a bromine ion with 36 electrons. So let's go find bromine. Bromine has 35, right? So 35 protons and 36 electrons. So it's like saying we have plus 35 minus 36 gives us, right, -1. Phosphorus ion. And note that if we do it the other way, it's fine also. So minus 36 plus 35 still gives us -1 either way, because all we're doing is we're just thinking about what our respective pieces are. Yes? Okay. So anyway, phosphorus ion, phosphorus, 15, right? So we have 15 protons and we have 18 electrons, which gives us, ding, 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 -3. Okay. And so we would like to find the number of protons and electrons in the S2 minus. So what is that? Right, the charge goes in the upper right-hand corner, so it has a charge of 2 minus, right? Which means that what happened to it? How does something become an ion? Right, it gains or loses electrons. So what that means is to become an anion, it gained electrons. How many did it gain? Right, this says that it gained 2 electrons. So if we go find sulfur, sulfur has 16 electrons to begin. So if it has 16 electrons, it has 16 protons definitely. It started with 16 electrons, but to get to a +2, it would have to have gained 2 electrons, right? So it means that we have 18 electrons, 16 protons, and if we look at those numbers, do they make sense with the 2 minus charge? Absolutely. All right, next up. So if we're taking a look at a periodic table, there are certain charges and certain ions that we can predict based on their location. So everything, going back to stuff you should have learned in middle school, right? All bonding and all ion formation, all interaction between atoms is about gaining a full valence, okay? All interaction between atoms, whether it's sharing of electrons or gain or loss of electrons, is about filling a valence, right? Where a valence, if you go back to middle school science, right? Valence is your outermost shell of electrons, right? And the goal in your valence is 8 electrons, okay? Again, we will put some detail to that in chapter 9, but for now, we're going to just roll with the things we already know, right? Valence shell is your outermost shell. Full means 8 electrons. So every atom is shooting for full valence of 8 electrons, either by gaining, losing, or sharing, okay? Since we're talking about ions specifically, we're talking about those species that are prone to gaining or losing electrons to reach that 8, all right? Now, this is where the periodic table becomes like a beautiful roadmap, and we're just going to do whatever requires the least moves to get to 8 electrons, right? So, for example, everything in this group has how many valence electrons? Right. 7, right? Based on its group number, based on the stuff you read in your book, right? Has 7 valence electrons. So the goal is 8, which means they need to gain 1, right? So this group needs to gain 1 electron. Its other option is to lose 7 electrons, right? Gain 1, lose 7. The shortest pathway, the least number of steps to become a full valence is to gain 1. If we gain 1 electron, what kind of charge does it then bear? Right, -1, okay? Now, next one. So this next group over here, right, these have 6 valence electrons. And again, we can gain 2. We could lose 6. 2 is the shorter number of steps. We're going to gain 2, which means these are going to have a charge of -2. And then, just following in the trend, let's get a color that's not going to match too much. This next one, right, -3. Yes, does it make sense? Okay. Now, flipping to the other side of our chart, right, here we have our group 1 metals, right? Note that hydrogen is over here because we'll talk more about it in chapter 9, but it behaves like these metals, but is hydrogen a metal? Hard no, definite no. So if I ask on your test or your quiz, give me the name of an alkali metal and you give me hydrogen, definitely wrong. All right, so these have how many valence electrons? 1, right? 1 valence electron. Now, the option is to gain 7 or, right, lose 1 electron. What is the resulting charge? Right, +1. And if we look at this next group here, oops, these ones do the same analysis, right? 2 valence electrons, odds are lose 2, gain 6, so they will lose 2 and have a +2 charge, right? Then that brings us over here to the other side of my table, right? Where boron, typically no, right? But this one, definitely going to be +3, which means it lost some, right? And then your book also gives you a couple other special ones, right? Like zinc is going to be +2, and this is going to be +1, right? Those are just special ones to remember going in that direction, okay? But anyway, so based on their location on the periodic table, we can know the charges of certain things, right? Then that might lead you to wonder, well, what about this special group here, right? The one that's right in between. It could gain 4, lose 4. Well, they often do neither, right? They often do neither. Okay. I wanted to stop the line there because technically these behave as metals, so they're a little bit special and different. But these don't gain or lose, right? They just don't often, they will more often than not share than form ions, yeah? All right. Then that brings us to the concept of isotopes, right? Which means same number of protons. Oh, geez. Same number of protons, but different number of neutrons. If that's the only thing that's different, how do we know two things are isotopes of each other? Right. They will have different masses. Right. Okay. Then that brings us to notation. How will we note this, right? So A is mass number, where mass number is the sum of protons plus neutrons, okay? Always protons plus neutrons, which means this is always a whole number, right? It's never going to have a decimal attached to it because it's a counting unit, right? I literally added up protons plus neutrons, okay? Whereas the mass associated with a mass number, going back to this chart, right? The mass associated with a specific mass number is not always going to be exactly the same, but it'll be pretty close, yeah? All right. Okay, so let's go ahead and do some practice. Okay, So what are the atomic number, mass number, and symbols for the chlorine isotope with 18 neutrons, right? So chlorine, 18 neutrons. Let's go find chlorine. Chlorine has 17 protons. And if it doesn't mention being an ion, it also has 17 electrons, right? Just things we ought to be able to come up with. So atomic number, 17. Mass number, 17 plus 18, which is what? 35, right? And then that's it, and we will have written the symbol for chlorine. Yes? Okay. Next up, how many protons and neutrons are in this isotope of potassium, right? So this number down here is atomic number, right? Also known as this, by the way, right? And this one up here is our mass number, which we already said is protons plus neutrons, which means that, so we'd go find potassium. Potassium is 19, which means that there are 20 neutrons. Yes? Does that make sense? All right. Fantastic. Next up, isotopes and weighted averages. So most of the elements, right, not all of them, most of the elements exist as there is a group of isotopes that all have their own natural abundance, okay? Which means that we have to do a weighted average where every piece contributes a little bit differently to the overall number, okay? Which is exactly like we calculate our grades in chemistry, right? So for example, we know that tests are worth 50% of your grade, right? We know that quizzes are worth, I think, 27%, and labs are worth 18%, which then leaves us with homework at 5%, right? So those are the representative weights of each, right? Which means that a test counts almost twice as much as a quiz. Labs count, I don't know, what is that? 1/3 as much as a test, and homeworks count for very little, okay? So what that means is, let's just run a number here, right? Let's say your test average is a 95, and your quiz average is a 75, right? Your lab average is a 100, and your homework average is a 100, right? So if we were going to set that up, thinking about, basic math stuff, right? When we do math with percents, what do we always do? Right, we always turn them into decimals, right? So we're going to take our 95 times 0.5 plus 75 times 0.27 plus 100 times 0.18 plus 100 times 0.05. And what do we know, like in terms of double checking, right? What do all percents add up to when they're part of the same pie? Right, they always add up to 100, right? So that's one of the ways we could double check ourselves, or if we just weren't sure what one of the pieces was, I don't know, like in an advanced problem, for example, right? You could figure it out based on the fact that they must sum up to 100. This average comes out to a 90.75, right? So, right, what's key here, right, is that this weighs more than this, right? As in, this has a bigger impact on the overall average than this does, right? And both of those have more impact than these do, right? But everything counts to the extent that its percent is, right? Does that make sense? Okay, which is why I tell you guys, right, that quizzes are meant to be your way to assess where you are and how you should study before the test, right? And quizzes are not supposed to be that thing where you get all like stressed out and feel like the world is ending because, obviously your quiz average doesn't have to be stellar for you to do pretty well in the class. All right, so calculating atomic mass, which is going to be the exact same thing we just did over here. All right, so magnesium has 3 naturally occurring isotopes with masses of blah, blah, and blah, and natural abundances of blah, blah, and blah. Calculate the atomic mass of magnesium, right? So same principle, right? And so note that these masses are similar to, but not the same as, your mass number, right? So this isotope probably has a mass number of 24, right? But its mass is not going to be exactly 24, right? Does that make sense? And that's always how it's going to be. So anyway, here are percent abundances. So that's how much each one counts, right? So again, we will take our individual pieces, so 0.7899 times 23.99 AMU, right, plus 0.1000 times 24.99 AMU plus 0.1101 times 25.98 AMU, right? Thinking about units, if I add them, right, they stay the same, so my unit is still AMU, right? And I would add those up and come up with my 24.31 AMU for magnesium. Yes, does that make sense? Okay, no worries, you'll do a lot of practice. Let's say, just a few tidbits, right? Let's say that it asks you to figure out what element it is. Well, we could go look at the periodic table and figure out, oh, well, what matches that, right? Because what's on the periodic table is the average atomic mass, right? Just things you should know. All right. Thank you for listening. Be good, and I will see you soon. Bye.